Hello everybody, I'm going to do a video today on our first sort of introduction to chance and probability. Okay, so I actually meant to record this lesson today live, but I forgot to turn on my camera, so I'm going to redo it here for you as best I can. So flip the camera around so you can see where we are starting from. Alright, so the first thing we talked about as a class was what sort of situations we would use these ideas of chance and probability. And we talked about gambling situations where you would bet on the chance of a particular outcome. We talked about the chance of a certain kind of weather happening. And then I showed everybody on my phone. I've just got a weather app. I'll show it for you now. And then down the bottom it's got low chance of precipitation, meaning rain today, and then it's got a percentage of 10% there, okay? And so that's, you know, based on all the information, they think there'll be a 10% chance of rain. All right. We also talked about anything to do with a certain event happening with a certain outcome, and really that's what chance and probability is all about. Alright, we did a little brainstorm. So up the top of this page we had the words or numbers we would associate with something likely going to happen. And then we had on this side about half a chance or 50-50 chance of something happening. And then below was the other end of the scale, I guess you'd say, where something was probably not going to happen. So we had words like... Mr. Braithwaite's class, so loud. We had words like impossible, low chance, unlikely, uncertain, and then we had sort of more casual phrases like 1 in a million or maybe, I think was somewhere there as well. Alright, and then over this side, maybe there it is, we talked about the different ways we could represent chance and probability, and we narrowed it down to 3 different kinds. Percentages, decimals, and fractions, okay, and the ways that we can show chance in a certain particular way. Okay, and then as a class we moved on to the different situations we could use fractions, decimals, and percentages to represent an outcome. Okay, we talked in my class about having an equal number of one colour blocks in a bag as the other, and then it would be a 1 in 2 chance or a 50% chance, okay? Then we got into a little bit more of a complicated situation where we had blocks of 4 different colours and all mixed together in the one container, okay? So I know there's a few boys that have trouble seeing colours, so I've written next to them the letter that the colour starts with. So red, the first one, 1 red, 2 yellow, 3 green, and 4 blue, okay? So imagine that they're all together in a container, a cup or a bag or something, okay? The first thing we talked about was how many blocks there were all together, and for here there is 10, okay? 10 all together. All right, and that word that we use to describe the amount of possible outcomes, we say that that is the sample space. Okay, so there's 10 blocks in a container. The first thing we decided to look at was what word could we assume or could we attribute to each of those different outcomes. So if I had 10 blocks, I'll just try to make this a bit higher. Let's try that. It's a bit messy, but anyway. Okay. And if I had 10 blocks all together, which I do, and only one of them is red, one of the words we could attribute, and we looked back in our books to this, was improbable. Okay. The second colour we had was yellow, so it's a little bit more likely than the red, but there's only 2 out of the 10, so it's still, we would say maybe unlikely that you would draw out a yellow from that group. It's not impossible because it is definitely a chance, but it's a small chance. Okay, green we had 1, 2, 3, so more than red and yellow. So you could write the word maybe if you like. That was not a very scientific word though. Let's say, could also be unlikely really. Okay, and then we have 4 blue out of the 10, so we're probably more likely to choose a blue than we are any other colour. But when you think about it, any other colour combined is 6, okay, out of the 10. So a good word might be possible there. Okay, so now we're thinking about the term theoretical probability, okay? And I've put all those words together, fractions, percentage, decimal, because you can represent it in different ways. But theoretical probability, get out of the way, you silly cord. There, teach you a lesson. Okay. The theoretical probability is if we were to predict with mathematical accuracy what the chance was of drawing a red, a yellow, a green or a blue, what would be the most accurate way we could represent that using a fraction, decimal, percentage? Okay, so when we think about a fraction, we're thinking of a part out of a whole. So the whole sample space for this is 10 blocks. So all of my fractions, these different numbers are going to be 10. Over 10, I should say. Okay, so we've got 1 chance of it being a red, so the fraction's going to be 1 over 10. As a percentage, that equates to 10%. As a decimal, that equates to 0.1. Now, when we're talking about chance and probability, we're thinking a decimal is between 0 and 1. Okay, so that's important to remember. Percentage is obviously 0 to 100%. And a fraction is a numerator and a denominator, but it depends on the sample space. Now for us it's over 10 for this example. Okay, so I've got a 2 out of 10 chance of picking a yellow, so it's going to be 2 over 10. Okay, and that equates to 20% or 0.2. Okay, green, we've got a 3 out of 10 chance, which is 30% or 0.3. And blue, which is the most likely of the colours, is 4 out of 10, which is the same as 40% and 0.4. Okay, so those that are really clever among us are probably thinking, I can bring that fraction down to be an equivalent fraction of smaller value, so that is the same as saying it's 2 over 5, and here we can do 1 over 5. It is okay when we're talking about chance and probability to leave it in its form like this, so okay, so don't worry if that's not quite making sense to you at the moment. Okay, so let's do a little experiment now, which is what we do when we work out the chance of something if we can. And we're going to do experimental probability. So the different kinds we've talked about, theoretical probability is if we were to predict with mathematical accuracy what our results would be. So out of my 10 picks, if I was to get it as close as possible, 1 of those picks would be a red, 2 would be yellow, 3 would be green, and 4 would be blue. Okay, but we know that each time we do some of these chance and probability experiments, we can't predict exactly what's going to happen. And remember, every time I pick out of a collection of things, every time I put something back and I take a new try at getting that colour, it doesn't remember what I picked last time, so every time the chance is the same, every pick that I do. Okay, I'm going to do this really quickly for you so you're not watching a couple minutes of me getting colours out of a cup, but I'll just show you what I've got here. I've got the same colours in the same numbers as what I've talked about here. And I'm going to pick them out one by one, but put them back in each time and see how close my data collection gets to my theoretical probability. So based on what I've looked at, I don't think I'm going to pick a red 10 times in a row. That would be very unlikely, okay? I might pick it once, but it's not guaranteed. And I think that most of my picks will be green or blue. Okay, so just before I start, I've just done up a little table. Sorry, this video is jumping around because we've got people coming and going for showcase. And I'm going to record how many of my goes I get for each colour, so red, yellow, green, blue. Okay, so the way that I've collated my results is in this data table, and I've just done a tally, so one stroke equaling one draw out of the colour. So if we have a look at my results, they're pretty close with one exception. I actually drew red twice out of my 10 picks. 2 times I picked yellow. Green I only chose twice, picked about twice, and then blue I had 4. So if we were to then write down that information in fractions, we would have 2 out of 10, 2 out of 10, 2 out of 10, and 4 out of 10. Okay? So the only 2 that were perfectly accurate with our theoretical probability was the yellow and the blue. Now, I picked 1 more than I had assumed from the red colour, and then 1 less from the green, but they're pretty close. It would be pretty amazing if I ended up picking like 10 red or 10 of any colour, really, straight. So we would then could convert that to decimals for each number, okay, and then percentages if we needed to as well. See, I told you when we're doing decimals and percentages and fractions in term 2 they'd be important. Okay, so the difference between the 2 tables that I've got here is theoretical probability, so predicting before I've actually tested it or completed an experiment on the data, and then experimental probability is the results from a particular time that I've done an experiment with colour or something else. Alright, that's a really brief introduction to chance and probability. There'll be lots more videos to come, but a good place to start.